Let's get started. I'm Janvi, he's Paul. We are both software engineers at Thunkable. And today we are going to talk about how we have integrated AI in our blocks and in our platform as a whole. So this is our agenda, short and sweet. We are going to talk about Thunkable cross-platform. So basically, it's our block generation program to create projects. And then we will talk about our challenges that we ran into while we were developing this system. After that, we're going to talk about Thunkable AI. So all the challenges we ran into made us work on something different than what we were working on before. So let's start with Thunkable cross-platform. So this is our main page. You can create a blank project or you can use AI, of course. So we have put in a prompt to generate an app for exploring landmarks of Cambridge. So it pops us into this preview. So as you can see, it has created a list of all the places you can go to. And then when you click on one of them, you can see the details about it, like an image, a title, etc., etc. So now when you get out of the preview, this is our main editor. So the first part is the designer. So you can click on individual components here, and here you can edit the properties. Also, this is like a data viewer. So we have all the data that we get from our data source. So our data source is basically a data table where you can edit the data inside it. This is generated with AI. So if you want something different, you can do that as well. Of course, this is the blocks tab. So all the major functionality of the app will be shown here. And I'll hand it over to Paul to explain how these blocks were generated using AI.
Cool, thanks. We're getting AI to go off and create these blocks. The question is, how do we do it? So the blocks are inside of our system are represented as XML. Yes, we haven't changed it either. Getting the LM to actually give us the exact XML that we need can be a challenge, right? We need to make sure the block type is right, all the fields are there, the mutation's there, the shadow's not. And if anything's kind of the wrong way, then the whole app may not even render at all. So this was not really a solution that we wanted to use. So for each of the blocks that we have, we actually turn them into JavaScript that then runs, and that's how we actually get things to run on mobile and on web. But if we actually look at the code that the JavaScript that's actually generated, I guess you can kind of see from the colors kind of where the blocks are. But you see there's a lot of other stuff around it. These promises and set state. These are useful for just making sure our larger system runs, for various optimizations. But it would be hard to kind of do a one-to-one mapping of the generated code to kind of the blocks that we need to be able to go back and forth. So this led us to creating what we internally call block.js. Basically, it's a JavaScript-like version of the blocks, but it's not the JavaScript that we actually go off and execute. So you can see this is for that little icon next to details. When that icon is clicked, it'll navigate to the landmarks. And we have a JavaScript that kind of nicely would go back and forth easily in a one-to-one relationship. So how does all of this work? So basically, we get the prompt from either the user or internally within our system because we'll be like generating maybe a screen at a time. And then we also have our block.js definitions. So these will be definitions of all of the possible components and methods that are possible for it to be able to use. We kind of send all of this to an LM. We use ChatGPT and Claude and a few other things. And then that gives us a block.js. And then, which can be the hard part, but then after that, we know if this block.js is what we're expecting, we're able to then take that and turn it directly into the blocks that we're going to use and the user will see. So this is for project generation, starting out with nothing, having a prompt, and then getting something out. But for editing it, we do just about the same type of thing. We'll take the prompt, we'll take those block.js definitions, but we'll also take the blocks that exist within the project, turn those into block.js, and then do the same type of process. Send them to provider of some sort, and get the new block.js out, and then go off and turn those into new blocks. So we ran into a number of different types of challenges while trying to accomplish this. From unsupported features, indexing, and kind of different audiences who have different types of needs. So let's start with the unsupported features. So let's say you're making who knows what. You can make things that require regular expressions. Pig Latin was, I think, one of the first things that ran into this. And then the block.js it gave us, not this particular one, basically gave us regular expressions. And we didn't have regular expression blocks inside of Thunkable. And then it's like, I can't render that, and then know what to do. For some unsupported features, what we're able to do is just add them to the system. So we've added various features actually because of this, from regular expressions to map and reduce, various things that users normally wouldn't just drag out, but ended up being things that with JavaScript, the LM was often giving us and enabling people to kind of create those full projects. But there are some unsupported features that were going to be harder to support. So we see inside of here, we have this button click, and inside of it has a when timer fires, and then it sets the timer to be enabled, which is reasonable JavaScript to have like an event inside of an event. But within kind of our Blockly framework that we use, we can't exactly put this timer fires event in the middle of this button click. So for these types of problems, we couldn't just add blocks to be able to make the problem go away. We essentially just tried to prompt our way away from kind of the solution, say, hey, don't do that. Please, please don't do that. And often that works. Ooh, they caught that. So another thing is sometimes people would, often this happened when people were typing in things or like large math equations or whatever else. And we'd get, some JavaScript back, and then we turn it into our blocks. And like default Blockly, Thunkable is uses one base indexing, but like JavaScript doesn't, and that led to sometimes you can prompt it and it'll figure it out in some cases, but in particular with like large things where it feels like it's probably just copying some formula from somewhere, it really doesn't get the job done. So this actually led us to, inside of our generated projects, we actually have the option to be able to use zero-based indexing to kind of optimize for what we know the LLMs are going to give us. So, which is kind of different because after all these years, we've been trying to figure out, okay, what's the easiest thing to learn to be able to do? And that kind of means we're building different types of things for different audiences. So within education, we are trying to get the students to learn computer science concepts. Often they're creating small prototypes and smaller based apps. And some teachers don't want to have AI on anywhere near their classroom. So we actually give them the ability within our EDU organizations to basically just turn it off. All the AI features are gone. And then some are great. We want people to use it all the time to be able to do it. And sometimes we have stuff in between. Use all the blocks, try to figure it out, and then kind of see what AI does. And that's very different from our enterprise customers who are not there to learn CS concepts at all. They just want an app. They want it to work. They want it to work quickly. And they want it to be robust. So that it's going to kind of work and scale for kind of whatever their needs are. Focusing, and I guess I will mention, even within that same enterprise solution, you also have like marketing students, for example, who aren't necessarily professors really don't want to teach the computer science concepts, but they really want the students to be able to get to a prototype to be able to demonstrate what they're doing, as we heard in the previous talk. So part of that led to the development of Thunkable AI, and it'll work this time. Similarly, you can, with Thunkable AI, you can start with a prompt. We'll do the same thing. We'll explore landmarks in the other Cambridge. Then it creates a chat window, as you've probably seen from other vibe coding-like platforms. You actually see that the code that's there is a JavaScript using React. This actually does not use Blockly. So within the editor, we still have a way of being able to preview. You'll see this is a bit more rich than what you saw from before, with search bars and filtering and a lot more information. But we still keep some things from Thunkables, from Thunkable cross-platform, being able to select particular components and be able to edit them within a properties panel. And then from there, you can actually look at the code for how this works. We not only is it just JavaScript, but in the same way as Thunkable cross-platform, we actually abstract a number of the APIs, both local things that are native to your phone and also third-party APIs to actually make it easier and simpler to be able to use the code that we have.
So yeah, so whatever your choices are, whatever your preferences are according to who is using it, you can choose Thunkable AI if you want to build robust prototypes and apps, or you want your students to go and create AI-generated apps with JavaScript, so they get a knowledge of JavaScript as well. And the second platform that we have is Thunkable cross-platform. So we are still continuing to teach basic, computer science concepts to students. Also build simple prototype apps. So you see the screenshot here is a bit simpler than the other one. And also, we have this AI functionality, so the teachers can decide whether the students want it or not want it. So interestingly enough, we have a curriculum that we use for students. Basically, they will start with the basic blocks, and then after that, in the end, they can use AI-assisted functionality that we have to polish it. So yeah, I hope this presentation has given you an idea of what Thunkable does, the platforms, and most importantly, using AI in blocks. Thank you.
Any questions? Yes.
Hi, Kirsty here. So in terms of the kind of chat interface for asking for an app, have you thought about or done anything in terms of a dialogue back? Like, what questions should the AI ask the student to make them learn something about app design in the process?
So our focus isn't necessarily to have them learn about app design as they're going, but we do most certainly ask questions. So in that first prompt, if it was like particularly vague, and we have some metrics for figuring that out, it'll actually come down and actually ask you a number of follow-up questions to figure out, oh, do you really want this stuff stored here or here? Or what type of app are you really trying to make? And actually gives you a bunch of like radio button options to be able to select. And then inside of our, inside the actually chat interface, it'll do the same type of thing. And we have a discuss mode where it'll sometimes give you possible options to choose. So yes, we don't always depend on the first thing someone's writing, just going off and building it. Depending on the types of problems that we think may come up or types of choices we think they may want to make, we definitely do ask ahead of time.
Okay, thanks.
For the cases where AI tried to use blocks that don't exist, have you considered asking AI to create the blocks that don't exist?
We have not done from scratch. Have you?
I have attempted. I have attempted to do it. It's not great. It will give you like a structure. It knows what a generator is. It knows what a block definition is, but it cannot like create something out of it. We still need a human for that.